Hello students. In last lecture we have discussed about what is called acceleration and retardation. Now in today's lecture we are going to discuss about how to plot a graph of distance against time, what is uses of that graph, how we can understand that from graph whether the motion is uniform motion or non-uniform motion. So let's start it. Okay, so here we are having two different tables, right? In first column we are having time t, and in second one we are having distance d. We are going to plot a graph of distance against time. Means on y-axis here we will have distance, that will be in meter. Okay, on x-axis we will have time, that is in second. Okay, from the given data let's try to plot the graph and let's understand that which type of motion is called uniform motion and which type of motion is called non-uniform motion. So let's do for this first case. So let's try for case 1. Before we plot the graph we have to also mention that what is there on y-axis and what is there on x-axis. Here we can see that on y-axis the 1 centimeter of distance, it is considered as 2.5 meter, means almost that 2 centimeter will be equal to 5 meters, and on x-axis we are taking 1 centimeter as 1 second. This is called scale measurement for graph. We have to show that what we are taking on x-axis and what we are taking on y-axis. On x-axis we are taking distance, on y-axis we are taking distance, and on x-axis we are taking time. Distance will be in meter and time will be in second. Okay, so let's start. Here, as we have done in earlier standards to plot the graph, first reading, it is at 0 second the distance covered by the object, it will be 0, and it is simple because the time is 0 means even the object has not started its motion. So our first point, it will be here like this. Okay, now second point, at 2 seconds of time distance traveled by an object, it is 5 meter. So here it is 2 seconds of time and it will be 5 meters. So our second point will be like this here. The third point, at 4 seconds it is traveling 10 meters. Okay, so when the time is 4, on x-axis it is 4, on y-axis we will get 10. Okay, the another reading at 6 seconds of time we are getting 15 meter of distance. So at 6 seconds of time here we are getting 15 meter of distance. The another reading when the time is 8 seconds we are getting it on 20. So when this is 8, here we are getting on y-axis it is 20. When the time is 10 seconds, here you can see when the time is 10 seconds, in such case our distance is 25. So when it is 10, I will get it here at 25. And when the time is 12 seconds, our distance is 30. So for 12 here on y-axis it will be at 30. Right? So this way we have plotted the graph. Now just join that, what we are going to get. See, here we are getting it in linear form, and also from the readings we can say that here at every equal interval of time, 2 seconds, 2 seconds, 2 seconds, 2 seconds, 2 seconds and 2 seconds, at this every interval of time the distance traveled by the object, first it was at 0 and it comes to 5, then again it travels 5 meter, then again it has traveled 5 meter, again it has traveled 5 meter, again it has traveled 5 meter, and again it has traveled 5 meter. So here you can see that at every 2 second of interval of time, the distance traveled by the object is same. Means we have studied in definition of uniform motion that the distance which is equal at every interval of time, it is considered as uniform motion. So this our first case, that will be our uniform motion. So here I am writing like this, that this is graph for our case 1, and from that case 1 we can say that this case 1, it is uniform motion. So always the graph of uniform motion, how it will be in graph of uniform motion in distance against time, graph of distance against time, if it is linear, so that will be in our uniform motion. Okay, now the second one. Okay, in second case, now let's try to understand it. So what happens in our second case? I hope you understood that why it is called uniform motion, because at every equal interval of time, distance traveled by the object is same, and always in distance against time graph, if it is linear, so that will be our uniform motion. Okay, we will make a note for it. Now let's check the second case. In second case, at first time it is at 0, so here it will be at 0. At second, when it is 2 seconds, we are having only 1 meter, right? So when it is 2 seconds, it will be nearly 1 meter. So we can plot the graph point here. Okay, when the time is 4 seconds, it has traveled 4 meters. So when the time is 4 seconds, it has traveled 4 meter. When the time is 6 seconds, it has done 9 meters. So here it is 10. So nearly it will be here 9 meter. When the time is 8, it has traveled 16 meters. So when it is 8, nearly here we will get as 16 meter. When the time is 10, in that case it has traveled 25. So in this case I will get it here. Okay, and when the time is 12, it has traveled 36, means it will be somehow here. Now as we connected the points, what we will get, this is for our case 2. Here we can observe that at every equal interval of time of 2 seconds, 2 seconds, 2 seconds, 2 seconds, 2 seconds and 2 seconds, in first case it has traveled 1 meter, in second it has traveled 3 meter, 4 minus 1, 3, right? In third case it has traveled 5 meter, in fourth case it has traveled 7 meter, in fifth it has traveled 9 meter, and in sixth it has traveled almost 25, so 11 meter. Here at every interval of time the distance travel is different. So according to definition of non-uniform motion, if the object travels not same distance, here the time interval is same but the distance traveled by the object is not same, so this second case is considered as non-uniform motion. And you can see that here if the graph is not linear, so it is considered as non-uniform motion. So this will be our second case. Okay, now from this given graph of distance against time, what we can say, suppose we are trying to find out the slope. Now take any 2 points like this, and for slope what we have to do, we have to find out this one, that is called slope. Always remember, slope means it will be y-axis upon x-axis. Now check this 2 points on y-axis. Okay, suppose here that is our S1 or D1, and here it is S2. Related to that, the time, that is T1, and here related to that, that is our T2. As we do like this, slope is equal to point on y-axis. We will take this 2 points on y-axis, so this will be somehow like this. So what we will get, this distance, so h2 minus s1, and on x-axis we will get this t2 minus t1. Okay, so our s2, it is 20 minus 10, our t2, it is 8 minus 4, almost we will get 10 by 4, which is 2.5. Now what will be the unit? As the unit of y-axis is meter and x-axis is second. Now see, of what quantity this unit is? It is of speed. So always this slope in graph of t against t, value of slope will always give us velocity. What it will be? It will be our velocity. So this is also important, that in graph of t against 3, value of slope, this we can consider as our slope. So value of the slope, this slope, it will give us velocity. Okay, so this way we can calculate the slopes also. Don't worry, this will be done in higher standards, but right now we are just taking that how we can do the calculation, how value of slope in graph of d against t, it is velocity. From this unit it will be, this thing we have to understand very well, that always whenever we are plotting any of graph, so slope will be always y-axis upon x-axis. Similar, this type of graph we can also do for velocity against time. Okay, now let's see what it gives. But before that, if this distance against times graph is given, right, so in this type of distance against time graph, slope value will give us value of velocity. Okay, if it is linear, so that will be uniform motion. If it is non-linear, so that will be non-uniform motion. So this much we have to study from graph of distance against time. Now where this type of graph is useful, so from this graph you can study that whether your motion, it is uniform motion or it is non-uniform motion. So to determine the type of motion, whether it is uniform or it is non-uniform, we can plot a graph like this. Also by finding the slope of distance against time, we can find out the velocity of the object. So these will be main uses of distance against times graph. As we have discussed about distance against time graph, here on y-axis we are having velocity, and on x-axis we are having time, that is in second. Here it will be in meter per second velocity, right? So we are having velocity against time graph. Now let's try to understand it. Same it is as distance against time. Okay, from that let's start to plot the graph. At 0 second of time, the velocity is 0, so our first point will be here. Then when the time is 5 seconds, here the object gained the velocity, it is 2.5, so nearly it will be here. In Another 5 seconds means when the time is 10, here you can see when the time is 10, the velocity of an object is 5. So when the time is 10, it is at 5. Third one, when the time is 15 second, in such case the velocity is 7.5. So 15, for that we will get 7.5. So nearly it will be here. For 20 seconds it will be 10. So for 20 we will get it at 10. And for 25, right, when the time is 25, here the time is 25, and you will get the velocity, it is 12.5. so it will be, for 25 it will be here 12.5. Now as we will join this, we will use to know that here it will be linear. So if the graph is linear, so here we can say that velocity is changed with respect to time, but the change in velocity is linear, means at every equal interval of time the change in velocity is uniform. So that is called uniform accelerated motion. That will be considered as uniformly accelerated motion. So what does this uniformly accelerated motion means? Here you can see at every equal interval of time, here we are having time interval of 5 seconds, and at this every equal interval of time the velocity which is changed, it is almost 2.5 meter per second. So at every equal interval of time, change in velocity is also same. So that is called uniform accelerated motion. So here we can say that in graph of v against t, if it is linear, so that is called uniform accelerated motion. And if it is not linear, same, if it is not linear, so that is considered as non-uniform accelerated motion. Here also you can see that velocity is increased, so that will be our acceleration. But if with respect to time, if our graph is somehow like this, right here, suppose it is uniformly decreasing, means the velocity is decreasing with respect to time. So we have studied in the topic of acceleration that if the, here in this graph, velocity it get decreases with respect to time, so this will be our negative acceleration, which is also called retardation. What it is called? Retardation. Okay, so this way we can plot a graph of it. Similar, as we have to find out the slope, suppose we want to find out the slope, this slope. So again, points on x-axis and same points on y-axis, we can find out. Okay, so here to find out the slope, the method will be also the same, like slope is equal to y-axis upon x-axis. On y-axis what we will have? Velocity. Right here we can see that it is 7.5, this will be our v2 and this is our v1. 7.5 minus 5. For that the taken time, it is 15 minus 10, so it will be almost 2.5 divided by 5, right? So it will be 1 by 2. Now what will be unit? On y-axis we are having meter per second and on x-axis we are having second. So this unit will be our meter per second square, which is similar to acceleration. Now, as it is similar to acceleration, we can say that this value of slope, it gives us value of acceleration. So this is also most important thing to note down, that in graph of velocity against time, the value of slope gives us acceleration. Okay, one more thing, if we find to take the covered area, or just find out this covered area, so if we take this rectangle as a covered area, so how we can find out its area? Length into breadth, right? So in that case, what it will give us, so it will be somehow like this, that length or breadth, so it will be like this, v into t is equal to covered area. So v into t means what? We have studied in formula of velocity that velocity is v is equal to d by t. So from that what we will get? We will get d is equal to v into t. So this is our displacement. What it is? D. So d will be our displacement. Okay, so this is also important thing to note down, that in graph of v against t, the covered area will give us value of d, that is our displacement. Okay, now for what this type of graph is used? This type of graph is used to find out the displacement. How we can find out the displacement? If we can plot the graph, and from that we can find out this type of covered area, right? So from this covered area we will always get displacement. If we find the slope, we can find out what is acceleration, and by the graph we will use to know whether the motion is uniform accelerated motion or uniform non-accelerated motion. Next we will study in our class.